Lesson 5.2, continuously compounded interest. Our objective for this lesson is to be able to use the continuous compounding formula to compute the balance in an account after a given period of time. Before we get to the vocabulary, I want to think about what would happen if we just kept compounding our interest more and more often. That is, if we had the same principal, the same amount of time, and the same interest rate, could we just keep making more and more money by just compounding our interest more and more often? So let's take our compound interest formula and let's simplify it a little bit. Let's say that our principal amount is $1. So we're just going to be multiplying by 1, so I'm just going to erase that. And then our interest rate, let's say our interest rate is 100%. So as a decimal, that would be a 1. So our interest rate is 1 or 100%. The n is what we want to keep in there because we want to compound this more and more often. And our time, let's say, just for 1 year. So we'll take that away too because that'll be a 1. So now it's 1 times 1 plus 1 over n to the n times 1 power. So we've kept everything the same. The interest rate and the principal and the time, we've just simplified it as much as we can. Now I want to see what happens if we compound our interest more and more often. So here we have, we're going to figure out what is going to happen if we compound it annually, monthly, daily, hourly, every minute, or every second. So if we compound it annually, the n is going to be 1. If we compound monthly, that's 12. Compound daily, that's 365. Compound hourly, that's 365 times 24, so that's 8,760. Every minute, well, fans of the musical Rent will know that there are 525,600 minutes in a year. And every second, that's going to be 31 million. Let me figure out what that is actually. 31,536,000 seconds in a year. So if we compound our interest every second, we're compounding it over 31.5 million times. All right, so now let's plug this in and see what amounts we're going to get. Well, the first one is easy. If we plug in a 1 here, that's 1 plus 1, which is 2, to the first power. That's just going to be 2. So we're going to have $2, which should make sense because we've got $1. We're earning 100% interest. So 100% of a dollar is a dollar. And so we have that original dollar plus another dollar. If we plug in 12 now to our formula, we get 2.6130353. So I'm carrying this out to a lot of decimal places, and you'll see why in just a minute. If we plug in 365 in for this n, we get 2.7145675. We plug in 8,760, we get 2.7182669. So you can see what's starting to happen here. When we compounded our interest monthly, we jumped from $2 all the way up to $2.61. Then when we compounded it daily, we made an extra 10 cents. But then when we went from daily to hourly, we only added another 0.4 of a cent. And now when we go to every minute, this becomes 2.7182792. And then if we go every second, this becomes 2.7182818. So notice that it's slowing down. We're gaining just a little bit more. smaller and smaller amount each time we compound this more often. And now we're up to 31 million times a year, and we've come up with this number, 2.7182818. And it turns out that if we just keep compounding this more and more often, we just keep getting closer and closer to a number that is about 2.7182818, and it'll continue on. It's an irrational number, just like the number pi, and it's about this value, about 2.71828. And we call that number E. E is a very important number in mathematics, and it's the number we're going to use to talk about continuously compounded interest. That is, interest that is compounded an infinite number of times per year. All right, so first I want to distinguish between two similar sounding terms. One is annual percentage rate, APR, which is the interest rate that would be paid if interest were compounded just once per year. This is usually what we mean when we talk about an interest rate. For example, annual percentage rate is the rate that we're going to use in our compound interest formula. The R in our compound interest formula is the annual percentage rate. On the other hand, there's annual percentage yield. So annual percentage yield is the actual percentage by which a balance increases in 1 year. So we talked about how compounding interest more often gets us more money. We're going to earn more interest the more often that interest is compounded. So annual percentage yield takes into account how often that interest is compounded and tells us how much we're actually going to be earning over the course of a year, given how often that interest is compounded. So now let's talk about continuously compounded interest. Continuous compounding means compounding infinitely many times per year. So we saw that the more often you compound the interest, the more interest you're going to earn, but that there's a limit to that. And so at some point we just say, well, let's just forget about how often we're compounding our interest. Let's just assume we're compounding it infinitely many times per year, and let's just use this number E in our formula and assume that our interest is constantly being compounded. So the compound interest formula that we're going to use for continuous compounding is A equals P times E to the RT, where A, P, R, and T mean the same things that they meant in our compound interest formula that we learned in the last lesson. A is the accumulated balance, P is the starting principal, R is the annual interest rate or annual percentage rate as a decimal, and T is the time in years. And then E, remember, is a constant. It's always going to be equal to this number that's about 2.71828. It's an irrational number, so those digits go on forever without repeating or without stopping, just as pi does. And E is a very important number, and because it's so important, there should be an E to the X button on your calculator. And so we'll use that E to the X button when we're performing calculations on this continuously compounded interest formula. A equals P times E to the RT. Our example says you deposit $100 in an account with an APR of 8% and continuous compounding. And it asks, how much will you have in the account after 10 years? It also asks, what is the APY? And we'll get to that in a minute. Let's first calculate how much money we're going to have in that account after 10 years. Now, it says that the account has continuous compounding, so it's continuously compounded interest. So that's going to be our formula, A equals P times E to the RT. And the principal is $100, and the rate is 0.08, that's 8% as a decimal, and time is 10 years. So if we plug this into our calculator, 10 times e to the 0.8, that's 0.08 times 10, we're going to get that this is $222.55. So that's how much money we're going to have in the account after 10 years. Let's now figure out the APY, the annual percentage yield. And to do that, what we want to do is figure out how much money we're going to have after 1 year. So if we go back here and take away this 10, just make this is going to tell us how much money we'd have in the account after 1 year. So if we plug that in, we're going to get $108.33. All right, so what we first need to figure out is how much money, how much interest will we have earned in 1 year? And so we've started with $100, we now have $108.33. So we have $8.33, or we've earned $8.33 in interest. Now we're going to divide this by the amount we originally put in there, so $100. And that's going to give us 0.0833. So the interest, our effective interest rate, or our annual percentage yield, is 8.33%, 0.0833. So our APR is 0.08, but because we were compounding this interest more than once in a year, our APY is going to be slightly higher. It's 8.33%.